Alright, so for this week's video, what I'm going to do is I want to walk through creating basically a Windows application that has two forms. We're not going to get overly complex with it, though it may feel a little complex at times. The idea is that you have a main form, which is your navigating form. That form will allow you to add users and remove users from a data source. In this case, it's just going to be a list of user objects. But I want to take you through the mechanics of clicking add user, popping up a new box where you input first name, last name, and email. You hit submit, and that user then gets moved to the main form and added to the list box. And then you can select the user from the list box and remove them. Okay? So it's just those mechanics of how do I take data from one form and move it to the other form in an elegant way. And if you have differences of opinion or thoughts on how to implement it, please feel free to share. Because sometimes I've had students throw out ideas and I go, oh, that's pretty, I like that. That's an even better way than I was thinking about it. So if you have thoughts or questions about it along the way, please ask. All right, so we'll do new project, Windows Form app. This is 15SS, CP week, we are on week 4. So again, Windows Form app under Visual C#, project name, and hit submit. So we have our form, our first form. And this form will basically have a series of controls. So I'm going to pull my toolbox out, go into my common controls. And what I'm going to do is I'm going to have 3 buttons. And a list box. And this box will be my list of users. My list box will be my list box of users. And this button will be btn add user. This will be btn remove user. And this will be btn exit. Okay. And I'll just call this form user management. Okay. So that'll be our form. In order to do this, we're going to need to add a model. So right click, add new folder. This will be my models folder, my classes folder. Right click there, add class. And I'm going to make a class called user. Public class user. And on this class, I'm just going to add 3 properties. First name, string, last name, string, email. The 3 properties, 1 model class. So again, the idea is that I go into a form, I type in first name, last name, email, I hit submit, that then adds that user to my list. Now, I'm going to start by wiring up my exit button. So I launch the app, I hit the exit button, it closes out. Simple enough. So I double click on the button, it gives me an event handler method. Let me enlarge this, move that out of the way. Now to exit your application, you have a lot of different options. because this form is going to be the main form, it's the primary form that launches. If you remember, that static void main has that run method and passes, it creates a new instance of form 1 and then passes that in. We could just say form.close, or this.close here, and that will close the primary form and in theory exit the application. But there are some caveats to that and we'll get into that later. But the correct way to do it is application, which is that utility class, dot exit. And by calling that, all of the Windows nests, if I can use that as a broad term, sends the appropriate messages and says exit the application. Shuts down all the forms, closes the app. So that's how you quit your application. The X that shows up on all your apps in the upper right hand corner, that is a operating system feature. What that X does and how that works, that's part of the windowing system within Windows. And that kind of just trumps anything that your app does. So basically you click that X, it closes that window, presumably closes the app. But as we get into multi-form applications, you'll see how there's some uniqueness about how these pieces work. So to exit the app, application.exit, call the function with parentheses. So if we launch the app, there's the app, we click exit and it exits. Simple enough. So within our form, I'll need that in a minute. What I want to do is I want to go up to the top of our form 1 class. So remember, our forms, they have a UI representation, but they're really just classes. So inside of those classes, just like our user class that we created a moment ago, you can add properties, you can add private fields, you can add methods, you can do essentially whatever you want to do because it's just a class. So anything you can do to a regular class, you can do to this form class as well. Yeah?
Up there where it's public partial class.
Yep.
Form 1.1 is form like a class that comes with Visual Studio, so it's inheriting everything.
Yes. So form comes out of the system.windows namespace. So in our application, under references, there's the system.windows.forms library that gets brought in as part of that template. Inside of system.windows.forms, if I mouse over, and I know it's probably kind of hard to see, it says that this class form comes from system.windows.forms.form. So it's a base class that comes with the .NET framework that our form inherits from, and that's why we get the windowing environment. If I were to grab that and rip it off, Visual Studio will totally freak out. Because it doesn't know how to deal with the designer and all of those aspects. You'll get one of these emergency type error screens. There's also, just if you're curious, there's another class that all of the user controls inherit from. All of these controls inherit from, which is system.windows.forms.control. And all of that gets inherited in to your controls. And if you actually dig deep enough on the forms class, it inherits from control as well. It's treated as a control by the subsystem. So all of the main functionality that comes into your forms and into your controls, that all is inherited by a base class, or through a base class. So at the top, what I want to do is I want to create a list of users that will be my data source for now. In a more complex scenario, you'd probably have a database or an XML document or some sort of third-party piece that is your warehouse for storing your data. But for now, we're just going to declare a list of users and use in-memory variables to store our users. So I'll do private list of user. And it can't find user because I have it in a subfolder, which means that it automatically generates that namespace So 15SS CP week 4.models, because I put it in a models folder. So here I get the red squiggle. But if I click on this accelerator, it'll say, do you want to add a using statement to this class, to this file, referencing 15SSCP week 4.models. It'll add that using statement above. So anytime I reference user as a class, it'll assume that I'm looking in that namespace. So with this private, I'll do underscore user data source. And that'll be the name of my private. And for me, I use the convention of the underscore just to denote that it's a private variable within the class. Kind of helps me remember, hey, this isn't public, or hey, this is just a field. It's not an actual property. So now I have this variable, but if you remember, just declaring this variable, it's an unallocated variable. It basically has a memory address, but it's empty. There's nothing there. So it's null. So I need to initialize this variable. Now I can do it in a few different places. I can do it in the constructor of the form. And when it comes to field variables like this, I recommend doing it there. So underneath this initialize component, which is what draws all the controls on the form. If you remember, we looked at that designer file last week, and inside of there it declared all of our controls and it set all of our properties and did all of that work. That's what this initialize component does, is it calls the function that does all of that work. I can say underscore user data source equals new list of users. So I've now initialized that list. I can now start adding things to the list. The other option is you could put that line in your form load event. And the way that I got that event was I went to my form and I double clicked on the title bar. And that generates the form load method. Form load happens when the form actually appears on the screen. Every time the form appears on the screen. Not every time the form is instantiated. So if you end up with a user experience where they click add user and then your form 1 disappears, gets hidden, then the next time it shows or loads, you end up potentially wiping out the collection of users. But if you want to go through a reset process on your form, then you would want to put your code in the form load. So things to weigh. So we now have this list in memory where we can store our user objects. What we want to do is be able to take that list and bind it to our list box. We want to take the contents of user data source and put it inside of this list box. And then every time we add a user to the list, it shows up in the list box. To do that, my approach, I'm going to put this method down here at the bottom, is to create a new method, private method, void, load list box. And maybe I'll be more specific. I'll say load user list box. And I can add comments to these methods. If you go above the method name and do 3 forward slashes, Visual Studio will do what's called, it's basically XML metadata. So if you've ever gone back and looked at the documentation, and I think we looked at some documentation last week, you'll notice that it says like, here's the name of the method and gives you some examples and some remarks and some explanations and all that stuff. That all actually gets pulled straight from the source. So when we do things like mouse over exit, and it gives me this pop-up says informs all message pumps that they must terminate and then closes all application windows after the messages have been processed. That comment is coming right from the source code of the person at Microsoft or the team at Microsoft that wrote that function. So as you're writing your code, you can actually put documentation right into your code. So here we can say that load user list box binds the underscore user data source to the LST user list box. We'll refresh as needed. Okay? So then if I come up here under form load, and one of the first things I do when that form loads is I want to refresh that list box, then I'll type load user, and you'll see that the IntelliSense pops me to that method. And it says binds the underscore user data source to the LST user list box, will refresh as needed. So my documentation actually gets consumed by Visual Studio and then presented back to me. So if I'm somewhere else in the application, I still have access to that documentation so I know what's going on. That works with methods. That works with classes. So I come in here, 3 slashes again. I have a summary. Represents a user in the application. Mouse over user, and there's my summary. There's also additional tags that you can add, including examples, remarks, C also, value, permissions, exception details. You can put all that documentation right inside of your code. For most of the small projects that we're working on as part of the homework assignments, it's honestly not worth the effort and time to document. But as you get into your final project and you start writing those class library classes and methods and all of these pieces, these moving parts, the documentation, even just to do the summaries, really starts to come in handy because at least it gives you a point of reference to say, what does this method do, or why did I add it? And sometimes you add some pretty unusual code. I mean, you're working with problems and trying to work around them, and sometimes you come up with interesting things, especially if you're working at 10, 11, 12, 1, 2 in the morning to solve a problem. So. So load user list box. If you're wondering how I managed to do that, I typed load U. It said that's my only option. Control space, auto completes, parentheses and a semicolon. So inside of here, what we need to do is bind the user data source to the LST user box. So LST user has a whole slew of properties, methods, events that we can work with. I keep using the term bind. Well, the reason for that is that we actually go through what's called a data binding process. You can point it to a data source. So there's data bindings, which are a subsystem for binding data sources to this. Specifically, they're used with the binding context for databases, and especially if you're using a lot of the drag and drop functionality to build your database connections. I will not be showing you how to use those. I'll be showing you how to actually write code to do it. So that way you understand what those little controls are doing. If you at some point in the future choose to use them, that's fine. But I think it's more important, at least for me, to teach you how they work instead of just dragging stuff on the screen and hoping that it works. So we'll be working directly with the data source property. The data source property takes in an object. And because it takes an object, it essentially can take anything. Specifically, it's looking for a collection or a list of items. So we'll say that the data source equals underscore user data source. Now there are some quirks and some hiccups with the way that this data source binding works, sometimes it works perfectly every time just by calling that statement. Sometimes it tries to be smarter than you, or at least thinks that it's going to be smarter than you, and tries to decide whether or not it really needs to do a rebind. So to force it, we're going to call LST user, which is the list box, dot refresh, and force it to do a refresh. There are still instances where I found that that doesn't work, and we'll get into those if it starts happening. So at this point, we're saying the list box data source is that collection of user data source. So we have that variable, that's our list of users. We called it underscore user data source. We're setting that as the data source for our list box. And then after we do that, we're initiating a refresh. We're forcing it to refresh and reload the list box using the data source. Yeah.
So does it automatically know how to display the user information? Like, will it know?
The short answer is no. It will try.
Yeah.
And I'll walk through what it tries to do, but it will try and it almost certainly fails. But there's ways of training it and showing it how to do it. Okay? So what I'm going to do here is I'm going to create a user and add it just right in the form load because I want to see what that looks like, and we'll actually go ahead and talk about that. So underscore user data source dot add, and then we're going to add a new user. And I'm going to do an inline initialization. So new user, and then instead of using parentheses to call the constructor, I'm going to use curly brackets. And this is a C# 5, I forget now. Yeah, they're on C# 5 feature, .NET 4 feature. And once I do the curly brackets, my IntelliSense will allow me to directly access those properties off of this new object that I'm creating. So instead of saying user u equals new user and then u dot first name, u dot last name, u dot and setting them, I can do it all in one chunk. Now I can actually break here, tab in for formatting, and I can still do them each on separate lines, or I can do it all in one line. So depending on how many you're initializing, kind of, you know, whatever's readable. So email. Now, because I'm doing the inline initialization, you don't do semicolons within the curly brackets. You separate them by commas. So first name. And then you can put a comma at the end of the last one, but you really don't have to, but it works either way. So we'll save that. So let me just kind of break down what's happening here since I'm doing it all as one big step. So this is just like algebra. You work from the inside out. So we have user data source dot add, and then we're adding this user. So think of the new user and the curly brackets as the user object that gets returned. So the first thing that the compiler and the execution engine do is they say, oh, well, you're calling new user. So it creates a new user, just allocates a spot in memory, creates that user. There's no variable per se, but it's just that user. It initializes email, first name, and last name of that new object. And then it takes that new object and returns it to the add user method, which then consumes it and adds it to the collection. And it only takes one semicolon to do it. So we've added this dummy user to the user data source. So now if we start, we rebuild. I know it's kind of hard to see, but it comes up with our user list, and inside it says 15 SSCP week 4 .models.user. Anybody know why? Okay. That's fine, I'm just wondering. Everything within the .NET framework, every class, whether it's a primitive or a user class, and pretty much a user class is everything except for those primitives, right? Except for ints, floats, bools, chars, anything else is considered a user class. It's a class. both primitives and user classes all inherit from object. Now, that is different from Java. All of your primitives are primitives, and then all of your user classes inherit from object. Because they inherit from object, they all automatically inherit these methods. They inherit the equals method, the get hash code, get type, member-wise clone, reference equals, and toString. So you can go up to any variable within your code, hit dot, and you will see all of those methods. They're always there. To my knowledge, there's no way to get rid of them. Not sure why you'd want to, but. So, of all of these methods, which one do you think the list box attempts to use? Any guesses? Equals. Equals is for doing a comparative between the two, seeing if object A equals object B, if they're the same. So, huh? What? What is the list box doing with this user object? What method, which one of these methods do you think it's using when it ends up spitting out basically the class name?
Is it toString?
toString, yes. So what happens is the list box says, I don't know how to present this, I don't know how to display. It's an object. It's not a primitive, it's not anything I know. So the easiest thing for it to do is say .toString. Converts it to a string, it can print a string out on the screen. Well, the default implementation for toString is to simply output what comes from getType, to output the type, the name of the class that the object is. So it's calling toString and it just spits out, I'm a user. I live in this namespace and this is the class name user. So to customize what appears in the text box, we actually have to override the toString method in order to get it to show what we want it to show. So if we jump back to user, tiny code. Now, again, I said everything automatically inherits from objects. So override, space, and all of the overridable methods that come from object are presented as part of the IntelliSense. So those methods are equals, get hash code, and toString. Now just a quick little backstory. Equals, you can override that if you want to explicitly ensure that maybe you have the base class and then you have an inherited class and you want to make sure that the way that that check is happening is basing it on maybe like an ID coming out of the database. So that's how you're going to determine the two objects are equal. You would want to override the equals. The framework itself actually goes through two steps to determine if two objects are equal to one another. The first step is it will call get hash code on both objects. Get hash code returns an integer. If the hash code is different, it will assume then that the objects are not equal to one another and that it's an automatic false. They're not equal. If the hash codes match, the framework, the runtime, will then call equals by taking one object, equals, and then passing the other object in. The default code that comes from the object class is for it to actually check the memory address of the two objects. So even though the two variables are objects, they have the exact same data in them, if they are not pointing to the same memory address, they are not equal, therefore they are different. That's the default functionality. Things like strings, for example, override the equals method, and instead of checking simply the memory address, it checks character for character to ensure that they are in fact the same string and are equal. Numbers, booleans, all of those work off that same convention. So if I create two users and I say the first name is Kevin, I'm both, the last name is Gantos on both, the email address is the same on both, and I say, are they equal? Because I've instantiated two different objects, it will automatically, without an override, say, no, these two objects are not equal, because they are actually in two different memory spaces. If we want it to say that they're equal, we have to override the equals routine. We have to override get hash code and attempt to calculate the same hash code. And then once we've calculated the same hash code for both, we then actually have to override the equals method and say, first name the same here and here, yes. Last name the same here and here, yes. Email the same here, yes. Because those all three match, yes, these objects are equal. So we actually have to manually determine that and return that it's true. ToString, same idea. So if we override ToString, it's going to, by default, return the base class's ToString method. Base class in this case is object. So we want to override this. So instead of calling this, we're going to return something like first name plus last name plus, and these are tabs, email. So I'm placing tabs in between. The tabs may end up being too big, but we'll start there. So by doing that, I'll hit save. I'll click start. We'll rebuild. And now it's Kevin tab, Gantos tab, and then my email show up in the list box. So if we want to change up that formatting, we can do this. We'll run it again. So now it's a little better. Kevin space, Gantos tab, email address. Now this doesn't give you quite as much control as like the data grid view, but the data grid view is relatively more complex in terms of how you work with it, so the list box is a good start. So we now have this list box. We have our users in there, our user, our one that we're loading in. So now we need to do the add and the remove. So we'll start with the remove because that's the easiest. And then we'll take our break and then we'll come back and do the add. So stop debugging, remove. Double click on the remove button. Brings me into my remove user event handler. What do you think the code needs to be to remove the user? What steps do we need to take? Yeah.
Find out which user is selected on the list box.
Okay.
And then remove that from the list. What's it called? The user list.
Do I move it from the list or from the data source?
The data source.
Okay.
Refresh the screen or
The list.
box.
Yep. Okay. Whoop. All right. So find the selected user. Step 1. LST user dot. So I typed SEL because I'm looking for selected. See if there's anything there. I have a select method. I have the selected index, selected indices, if I have the ability to select multiple list items. Selected items, again, multiple items. Selected value, and selection mode, which is that toggle of single versus multiple selections. There's also some events that go on in here that we can wire into. We'll get into event wiring later. So, let's go ahead and grab the selected item. So if I mouse over selected item, we'll notice the pop-up explains it as being, it's returning the type object. And one thing that I love and hate about most of the Windows Form user controls is that they are super generic. So you can pretty much put anything in them, but once you put a variable in there, unless you actually are paying attention to what you're doing, you can quickly forget what's in there and therefore what you're going to get back out. requires you to do a lot of casting. So this is going to return you an object, but that object is actually a string. No. User. It will actually return you back the user object, but you have to cast it back to a user in order to do anything with it. So we'll say user, selected user, equals, and then to cast, parentheses, user, before the variable name. So we now have the user item. The next step is we have to be able to remove that user from the data source. Now to do this, we could go through a lot of fancy magic and wizardry and loops and all kinds of stuff. Instead, I'm actually going to come back here and I'm going to do 2 more overrides. I'm going to override get hash code. And what I'm going to do here for my hash code calculation is I'm going to do it relatively simply. First name plus last name plus email all together dot get hash code. So I'm concatenating those 3 properties together. First name, last name, email. I'm generating a new string, and then from that I'm generating a hash code using the default method. If you read through the .NET documentation, they basically guarantee that if you try to generate a hash code off of 2 strings with the same value, you should always get back the same hash code. So this is a quick test to say, well, are these 2 user objects even the same? Like, do they have the same strings inside? Sometimes it just takes a little bit of creativity to come up with a form of generating a hash code. The easiest way to generate a hash code is if you're creating an object from a database. And your database uses integer primary keys. Well, this is expecting an integer to be returned, so you just simply return the primary key as your hash code. And if you've got 2 objects from 2 different rows, they should have different primary keys, therefore they won't have the same hash code match. So we get hash code easy. Override 2 R's equals. I always like to leave the base equals option in my methods, and you'll see why in a moment. Basically what it is if I'm wanting to see if this object is equal to itself, I have to do what's called an explicit cast, similar to what I did with the selected item, where I had to actually cast it to a user. Because if you notice, what's coming in here is just an object. You don't know that it's a user. I can take that user and say, is it equal to this string? Well, you could write a case for everything else, or you could just let the default do it for you, which is my recommendation. So I'm going to check if OBJ is a user. If it is a user, I'll see if they are equal, and if not, I'll just take the default action. So to check if an object is of a particular type, we say if obj is user. Is a reserved word, and it will basically check to see is obj of type user. And if it is, great, and if it's not, it will say false, and then you can move on. This saves you from having to attempt to cast something and then wrapping it in a try-catch block, and then maybe it fails, and all of this extra code. You can simply say, if obj is user true, okay, you can cast it as a user and it'll do it successfully. So we will do user, obj user equals casting user obj. Pull that up there for people in the back. And then I can say if this dot first name equals obj user dot first name, and this dot last name equals obj user dot last name, and this dot email equals objuser.email, return true. I'm not going to bother putting a false. Well, I guess I could put a false and save the computer a little bit of calculating. So basically, if the object is a user, go through this work. If not, use the base class equals and let it figure it out on its own. It'll probably be false, but you could have some weird inheritance going on or something else, and maybe you just want to let the default do its thing. But in here, we're doing explicitly, do the first names match, do the last names match, do the emails match. If they all three match, as far as I'm concerned, they're the same. Yes.
Wouldn't you want the return false like outside the other if statement also in case?
Well, this should return false
Okay.
automatically. Not automatically, but you would assume that this will do the check and it'll return false.
Alright.
Because if it's not a user object, it's something else. So they wouldn't be equal.
Yeah.
This is user is also nice because let's say that this object, let's say we have our user class and then we inherit from it and create some other class, student. Well, student inheriting user still makes it a user, right? We could maybe extend it and add like a student ID property and some other stuff, but it's a user because it inherits, just like the form. We inherit from forms, so form 1 is form 1 and we're doing other things to it, but it's still a form. So if it's a student inside of OBJ, it can still be cast as a user because it inherited from user. So we want to make sure by doing something like this that we're allowing for that inheritance check. Because if we have maybe a student and comparing it to a user, if they are the same, we want to be able to accommodate for that. And that will do that for you. If you want to do explicit type checking, where you're saying this is a user object versus a student object, then you actually have to do the get type and actually grab the type from the variable. And that's called reflection, and it's actually a very awesome thing, but I won't get into that today. So that will be our check. So if we come back here to our form, I'm going to say user to remove equals underscore. So I'm going to look at user data source, and there should be a find. Oh no, I'm sorry. Index of is what I want. That's going to give me the int. So let me move this down. And index of user. So grab the index of that user within user data source. And that user will be my selected user. So I'm taking the selected user that I grabbed from the list box, casted it as a user. Index of will find the index position within the collection. That, square bracket 0 or whatever you want to think of it as. It finds that position within the collection of where that user lives. This index of identifies if the user is a match by using the equals override that we just wrote. So by implementing equals, we can simply use index of, and then it will use that equals override to figure out if the user in the list matches the user that was selected from the list box. And then give us the position or index of that user. So that'll give us the index. Then we can say user data source remove at takes the index. Then we'll say index of user. Oh, sorry about that. And then the last step is load user list box. build and run. So there's our user, right? Came from our form load. Now we should be able to hit remove and remove that user. Stop it, run it again. I put a breakpoint there for when we enter so we can debug through this. So clicking in that gray margin puts a dot there so we can debug. When we start running again, we're running in debug by default. So I'll go ahead and click remove. Visual Studio will then stop at that line. We can look at the selected item. So it is Gantoka UC Mail Kevin Gantos. We do the cast. If I use these navigation buttons here at the top, I can step into, step over, or step out of. In and out have to do with, do you want to step into a method or do you want to step out of a method? Do you want to go deeper into the code or do you just want to run that line of code? Or do you want to get out of a method that maybe you got into? Step over is going to be your default button, which is the one in the middle. So you want to step over that line of code, you want to go to the next line. So I'll go ahead and step over. That means that that line runs. The line in yellow has not executed yet. Any lines prior to that have run, any lines after that have not run. The line currently in yellow is waiting to be executed. We're actually paused mid-execution of the application. We can inspect these variables. So again, there's our selected user. Here's our user data source. So you can see inside of that collection or that list, we have one item in there. The Kevin Gantos, and it calls that toString to present it again. So we'll see that same output. So we'll step over. The index of that is 0. So it's the first position in the collection. That's the item we want to remove. So it's now going to remove the item at position 0. We step over. We peek inside of user data source. Can twirl that open. You'll see that it says count 0, which means there's nothing in there. Therefore, it shows us no contents because now the list is empty. So everything's working the way we'd expect it to. In terms of the maintenance that's happening on that user data source list. So now I want to step into load user list box. So I'm going to do the step into. It's the first button of that set of 3. I now stepped inside of that function, and now I can step through each one of these. So I start there, step over to the first line. So user data source, still the same, 0 items. I'm going to set that data source again. If you look at the data source here, it says 0 items. So it's actually, remember, it's by reference. So it actually is pointing to user data source already. So we're kind of overdoing it by doing it again, but safe than sorry, because obviously it's not refreshing correctly. So we'll do that. Data source count is 0, so they're essentially the same. And then this refresh should refresh the control. But we still have an item in the box. Huh?
Would you call application.doEvents?
So one approach to that is to call application.doEvents. Which basically tells Windows to process all draw activities within the queue. So everything that happens in your Windows applications happen as a queuing process. So you can have, you ever had that point in time where the app kind of freezes up and you type and nothing happens, and then all of a sudden it like catches up with itself? Well, all of those keystrokes go into a queue. that queue is processed, and typically it processes in real time. But occasionally you have something that either happens within your application or another process within the computer that causes that queue to back up. It stops processing queue items, and then it catches up to itself, outputting the rest of your keystrokes. Because if you think about what your computer's actually doing is that you've got multiple applications, services, and all these other things happening. So your processor basically round robins through every process on your computer, doing a little bit of work for everything one at a time. And as computers get faster and multiple cores, it can load balance that and do other things. But that's the essential idea, is that it's not focusing just on your application. It's doing that and everything else that keeps the computer up and running. So by calling do events, you're saying process that pump, do the rest of that work. So let's try that. So we hit our breakpoint again. I'm going to click the red dot to remove the breakpoint. I'll hit continue to keep running. And do events did not take care of it. So it's not a queuing issue of needing to wait for the events to happen. Do events is somewhat of a heavy task. Not heavy, but it's relatively heavy. It can be a heavy task because you're waiting for it to process all the additional outstanding events. If you don't have to call it, don't call it, is basically the moral of what I'm getting at.
When you refresh the form, does it actually go back to the load process, the function, form load function?
No, it does not. It's supposed to just refresh the list box itself. It's supposed to reprocess the contents of the list box.
Because if it goes back to the load process, it will actually go ahead and print the whole thing again.
Correct. And there's also some paint functions that you can call, but that form load is, you're just handling the event of the form load process. So you're kind of wiring into when that load occurs. All right. Why don't we go ahead and take a break? I know I've been going for almost an hour, so let's go ahead and take a break. And while we do that, we'll come back and then we'll talk about how to fix this, and then we'll talk about getting data from the other form into this one. Okay?